Welcome to Science Manthan, and let's dive right into this fascinating explainer on the physics of position and motion. I am absolutely thrilled to guide you through this today. We navigate the world every single day, right? We're walking, driving, and watching things zoom past us all the time. But how often do we actually stop and define what it means for something to be exactly where it is, or what it truly means to move? Well, today, we're going to break down these core concepts of physics and kind of map out the actual mechanics of our everyday world. So to kick things off, let's look at a fun little riddle. Imagine you ask 5 different friends this exact question. Is the garden nearer or the school? Now imagine getting 5 completely different but entirely correct answers. No way, right? How is that even logically possible? Well, think about it. One friend might be standing right at the school gates, while another is just chilling on a bench inside the garden. Another might be all the way across town. They're all giving you a factually correct answer based entirely on where they're currently standing.
And you know what? The secret to solving our riddle is something physicists call a reference point. This is absolutely crucial. It's the anchor, a fixed place that we use to compare and describe the position of an object. Without it, we simply can't describe any position correctly. It's like a giant puzzle. You can only describe where a piece goes by comparing it to the fixed pieces around it. Think about how you give directions to a friend. You might use a bus stand, your house, or train station as your anchor. Without choosing one of those reference points first, the position of an object just kind of hangs in a void. It literally can't be described accurately. And this matters immensely. Everything from the GPS on your phone to how astrophysicists track planetary movements relies entirely on establishing this anchor first.
Let's put this into perspective. Think about the last time you were on a road trip. A simple highway milestone perfectly illustrates how we use reference points every single day without even realizing it. When you're driving and you see a board displaying Delhi 70 kilometers, what's actually happening there? Delhi is acting as your reference point. It's telling you your exact distance from that specific city. And as you keep driving and that number ticks down from 70 to 60, you instantly know your position is changing. You are getting closer to Delhi. Okay, now let's mix a crucial ingredient into our reference point: time. Figuring out whether something is at rest or in motion completely depends on tracking its position over time against our chosen anchor. If an object's position doesn't change as time passes relative to that reference point, we say it's at rest. But if its position does change as the clock ticks relative to that exact same anchor, then boom, the object is in motion. So both position and time are the whole shebang when it comes to describing motion. Now this spills into something even more mind-bending: relative motion. Picture this. You're sitting inside a moving bus. If we use the bus itself as your reference point, you are perfectly at rest. You aren't moving from your seat at all. But if we suddenly switch the reference point to a tree planted firmly on the sidewalk outside, you are moving incredibly fast. This perfectly shows that motion isn't some absolute state. It depends entirely on the reference point you decide to choose. Section 1, the geometry of movement, types of motion. So now that we've unlocked how perspective basically dictates movement, let's explore the 4 distinct types of motion objects take in our world. First up on the list is linear motion. Just like it sounds, this happens when an object moves along a perfectly straight path. It is everywhere. Think of a car cruising down a completely straight highway, an elevator moving straight up and down, or even a stone dropping directly to the ground. They are all following one simple, straight line. Next, we've got circular motion. This is when an object moves along a circular path around a fixed center. And that fixed center, that's the absolute key here. This type of motion is beautifully shown by things spinning around a central axis, like the blades of a ceiling fan in your living room, kids spinning around on a playground merry-go-round, or the hands sweeping across a clock face. The distance from the center stays exactly the same while the object traces a circle. Then we have that rhythmic to and fro movement known as oscillatory motion. An object does this when it repeatedly moves back and forth about a fixed position. A classic everyday example is a playground swing rocking back and forth, or the pendulum of an old grandfather clock ticking left and right. Even a metal strip vibrating after you pluck it is showing oscillatory motion. It just constantly passes back through its central resting point. Finally, we arrive at periodic motion. Now this one is kind of like an umbrella term, and it's where it all connects. By definition, if a motion repeats itself after equal intervals of time, it's periodic. So here's the cool part. Because circular motion, like a clock hand finishing a circle every minute, and oscillatory motion, like a pendulum taking exactly 1 second to swing back and forth, repeat at regular, predictable intervals, they actually fall right into this periodic category too. All right, let's pull all of this together into a clear map. Here's a quick cheat sheet so you can see exactly how these 4 classifications match up with the everyday movements happening around you. We've got linear, giving us straight lines like falling stones. We've got circular, bringing us spinning fans. Oscillatory gives us swinging pendulums. And periodic basically encompasses those repeating patterns, like the reliable hands of a clock. So, as we wrap up this explainer, here are your main takeaways. While standard units and the right tools make sure our measurements are uniform worldwide, the biggest thing to remember is this. To truly measure position, you always need a reference point. Motion itself depends entirely on changes in position over time relative to that specific anchor. And lastly, when objects do move, they do it in linear, circular, oscillatory, or periodic patterns. I'm going to leave you with this final kind of perspective-shifting thought on the universe. If motion truly depends on your chosen reference point, is anything in the universe ever genuinely at rest? It's a pretty wild question to ponder next time you're just sitting still. Kindly like, subscribe, and share for such more science-related videos. Drop your comments and queries in the comments section, and we will catch you in the next one.